Let's go ahead and look at an actual example of kind of a geometric problem where we're going to use that principle of segment addition. So the entire segment here, the whole thing, is just AC. I'm just going to use the length of AC here, so I'm not going to put the line above it. They're somewhat synonymous, and it makes a little more sense since we're actually talking about a measurement, 145, but same concept. And we have that whole piece, and that whole piece is broken up into two pieces. And so if we add up those two pieces, then they have to equal the whole thing. Again, if we travel from here to here, and then we add that to part BC, well, that takes us all the way from A to C. So AC equals AB plus BC. Now again, this is just to illustrate kind of what's going on in a general way. The nice thing about writing it this way is that if I then change these values at all, that relationship doesn't change. It's just the numbers that change. So this is kind of a more generic formula almost for this particular problem. All right, so let's actually plug in the values that we're working with for this particular problem. So AC is just 145 units, AB is 5x plus 7, and BC is 8x plus 18. And everything's color-coded, so if you need to pause for a second, just make sure you understand what's going on. That's probably a good idea. You'll also notice that I put everything I substituted in parentheses. It's not that important in this problem, but tends to save you a little bit of grief especially when you're dealing with negatives or distribution. What I've done is I've created a relationship where I'm looking for what value of x makes this true. And I'll actually put in here, it could be more than one value. To do that, let's go ahead and use our algebraic solving techniques and figure out what value of x will make this segment AB plus BC equal the whole thing, which is the geometric relationship that we're seeing. So let's combine like terms. All right, now I want to get that x all by itself. So I'm going to get rid of this positive 25 using its opposite, negative 25. And lastly, I have 13 groups of x. I'm going to divide that into 13 equal pieces, giving me 1x. And if I do that to the right side, I have to divide the thing that's equal to it, the thing on the left as well. And I'll just rewrite that in the reverse order there. Some of you might be saying, uh-oh, I have an improper fraction. A teacher sometime told me I can't have improper fractions. Improper fractions are actually great, and they're actually the best thing for calculation, but they're generally not as good for measurement. And since we're talking about geometry here, it might be useful to go ahead and rewrite this as a mixed number. 13 goes into 129 times, and then there's going to be 3 left over out of 13, and that is a perfectly good answer. Now we could also write an approximation as a decimal to give us a kind of even better idea, because 3 over 13 can be a little bit confusing. And so we get that this is approximately equal to 9.2308. Now I want you to keep in mind, again, both of these answers here are our best solutions. They are exact. And this last one here is just an approximation. Approximations are great some of the time to give us a really good idea of what the value is we're working with. But obviously, if we need more precision, we want to go back to our exact answer. Now, it's all great. We have this solution, but are we sure that it's correct? Well, we can use this formula that we came up with here. We know that we're looking for an x value that makes this statement true. So let's just plug it in and see if this makes it true. All right, and let's go ahead and plug in that 120 over 13, since I did mention that is the best number there for calculation. And I'm going to go through all the steps of solving this now, but obviously if we have a 13 here and there's some addition, we're likely going to need a common denominator. So I'm going to go ahead and kind of get things started on that. And now we're going to add all of these up. And again, this is a check step. We're checking to see if these two sides end up being equal to each other. So we'll add all our numerators and divide and see what happens here. And 1,885 does in fact equal, or divided by 13 does in fact equal 145. So we have in fact found the x value that makes this true. And again, if you really want to be sure, you can always plug these values into the diagram here. That's entirely up to you if you want to play around with things. But this gives you a pretty good idea of how the segment addition postulate or theorem, can't quite remember which one. I think it's a postulate. Should be a postulate. Anyway, how it works and how you can apply it in a kind of, generic geometric situation.